Today we are discuss about the theory of neutron rings. So in past videos, what is the how to making the Newton's ring formation of by Newton ring experiment we have briefly discussed. So in this video, to determine the what is the diameter of dark and bright rings, from theoretically we can calculate now. So let us see that this diagram. So in this diagram, L be a lens placed on a glass plate P. So this glass plate we have considered for P simple. The this convex surface of lens is the part of spherical surface with the center at a C point. Let from Q to C. So in this distance, let us consider for R. What is the meaning of R? That is the radius of curvature. In this spherical surface of the lens, from P to E, from P to E, what is the distance means? That is the R. That is mean radius of Newton's ring corresponding to the plane. Now we see that from P point to O point, from plane glass plate and convex plano convex rest between what is the distance means, that is the T thickness of the plane. Let us consider. So in this diagram, we can calculate what is the diameter of the ring. What is the condition after theoretically now we can derive. From the property of the above circle, now we can write it. What is the equation from plano convex lens surface PF into EP, PF into EP or PE, you can write it. That is equal to OP into PQ, OP into PQ. So substitute these values from Q to C and C to P values and E to P and P to F values substitute here. So what is the PF? So in this distance R means the same distance, that is the radius of the curvature from P to F. So this distance also R. So R into PF equal to R, P equal to R, that is equal to OP. From plane surface to this distance, what is the distance means? That is a T distance. So T into PQ. From this point to this point, what is the distance means? They don't know. We know that from C to Q, in this distance R, from C to Q, that is distance also R. Now we can subtract the total distance minus this distance means, you know that PQ, that is OQ minus OP, OQ minus OP, that is equal to QP. Okay, so QP equal to QO. What is the distance from CQR plus COR? So R plus R, 2R minus PQ, this point, 2R minus, so this distance you can subtract. Then you can say that PQ distance value. So PO value T. So 2R minus T. R into R, that is equal to T into 2R minus T. So from in this equation, you can multiply that R into R square, that is equal to T, you can multiply inside. So 2RT minus T into T square. Now we see that in this diagram, T is a very small distance from P to Q, that is a very small distance compared to remaining place. So in this equation, T and T square. So T is a very small. Yeah, that is already very small. So T square means that is a very, very small. So you compare the T and T square is a negligible. So in this above equation, T square is a negligible means remaining term you can write it. So R square equal to 2RT. R square equal to 2RT. So in this equation, we can determine what is the thickness of the film. So T only we can determine. So T only kept it in the right hand side, left hand side, remaining term on opposite side. So T equal to R square divided by 2R. T equal to R square divided by 2R. So T values, you know that. Now we can apply that what is the bright fringe condition and the dark fringe conditions. Already in the Newton ring experiment, we can calculated, we can derived that bright fringe condition and the dark fringe condition. So that conditions, you can apply that thickness of the film value. So in the bright fringe conditions, what is the general condition? 2T equal to 2n minus 1 into lambda by 2. So now the t value substitute here. 2 into t. What is the t value? R square divided by 2r. You see that t equal to r square divided by 2r. So 2 into t r square divided by 2r equal to 2n minus 1 into lambda by 2. 2n minus 1 into lambda by 2. So in this equation, 2 cancel. R square divided by capital R equal to 2n minus 1 into lambda by 2. So I want only for what is the radius of the curvature, R values only. So R square value only, I will kept it left hand side, remaining term move on opposite side. So this capital R, that is the radius of the curvature. So this capital R division term move on right hand side means that is a multiplication. R square equal to 2n minus 1 into lambda R divided by 2. So in this equation, we can calculate R is a radius of the curvature. But we can derive in this the Newton ring experiment, we can calculate what is the diameter of the bright ring and what is the uh, diameter of the dark ring. So the diameter value only we can calculate. So in this diagram, you see that. So this is the radius of the curvature from this point to this point. So this is from here. Here is the radius of the curvature. So I want what is the total diameter of this circular ring means. So already you know that how to calculate diameter equal to half of the radius. So this is the 1r means. So this another half is the another r. So r plus r equal to diameter equal to 2r. You can multiply 2r 2r diameter equal to 2r. I want r value only. R only kept it one side, remaining 2 multiplication term move on opposite side means division. So r equal to d by 2. So the r value substitute in this equation here, r can be replaced to d by 2. In this above equations, you substitute the r values. So the diameter of the nth bright ring, you write it here. So r can be replaced to d by 2. R square is a t square divided by 4. That is equal to 2n minus 1 into lambda r divided by 2. 2n minus 1 into lambda r divided by 2. So you can cross division term 4. You can move on multiplication term means that is the multiplication term. So d square equal to 4 into 2n minus 1 into lambda r divided by 2. So this 2, this 4 you cancel means 2 times. So 2n minus 1 into 2 into lambda r. So that is a d square. So you know that d means that is the diameter of the ring. N is the order of the ring. Lambda is the wavelength of the light. R is the radius of the curvature. So in this value, we can determine diameter of the ring only, we can calculate. So in this equation, you see that this is a d square. So I want only diameter of the ring. Take square root both the side. So square root of d square. So square root cancel, you can get it only square root of d equal to the right hand side square root of 2n minus 1 into square root of 2 into lambda r. So in this equation, n is the number of the ring. So n is a variable. But lambda is a source of light, that is a constant. R is the radius of the curvature. So which plano convex lens you use, that radius you can, that values you can use it here. So this is a constant. Yeah, so this is a constant. So in this equation, you can write it d is directly proportional to so in n is the order of the ring, n equal to 1 2 3 n numbers given that. So you just this n value substitute in this above equation means what is the value you can get it means. So I will 4 examples I given that 4 values substitute in this here. Then finally what is the answer you can get it. You see that here. So n equal to 1 I substitute here. So d is directly proportional to square root of 2 into n. What is the n value? 1 minus 1. So d is square root of d is directly proportional to square root of 2 minus 1 1. So square root of 1, n equal to 2, substitute here. So d is directly proportional to square root of 2 into 2 minus 1. 2 into 2, 4 minus 1, 3. D is directly proportional to square root of 3. N equal to 3 means d is directly proportional to 2 into 3 minus 1. 3 twos are 6, 6 minus 1, 5. D is directly proportional to square root of 5. Now I will substitute n equal to 10 means, so D is directly proportional to square root of 2 into 10 minus 1. So 10 into 2, 20, 20 minus 1, 90. You see that in this result, square root of 1, square root of 3, square root of 5, square root of 19. So whatever may be. So any order of this values or numbers you substitute here in this formula means you can get it only for odd numbers. Okay, so odd natural numbers only you can get it in this bright fringe conditions. So we can conclude in this bright fringe conditions, the diameter of the bright rings are proportional to the square root of odd natural numbers. Square root of odd natural numbers only occur in these conditions. Next to go for dark ring conditions. Already we determined what is the dark fringe condition. 2d equal to n lambda. So t values, you know that t value substitute here means 2 into r square divided by 2r, that is equal to n lambda. So 2 2 cancel. Now we can get it r square divided by r, that is equal to n lambda. So now I want only for r values, radius of the curvature, r square equal to this division term move on right hand side means that is the multiplication. N lambda r square equal to n lambda r. Already said that that is the radius of the curvature, so we can determine that diameter of the ring. So r can be replaced to d by 2. So this r value substitute here means, so r, this is r square, so r equal to d by 2 means r square equal to d square by 4. D square by 4 equal to n lambda r. So d square only kept it left hand side, remaining term move on opposite side. So this division 4 move on right hand side means multiplication. 4n lambda r, d equal to square root of 4n lambda r, d equal to square root of 4n lambda r. So in this equation, lambda r, that is a constant, 4 also constant, n is a variable. So d is we can square root, we can split it. D equal to square root of n into square root of 4 lambda r. So this term is a constant, only variable this one. So D is directly proportional to square root of n. Now we can, you know that the dark fringe condition n values 1 2 3 4 etc up to n numbers. So n d is directly proportional to n means, so n equal to 1 means you can get it 1 2 3 4 whatever may be n numbers you get it. But what you finally you can get it, all the natural numbers occur in this diameter of the dark ring conditions. So we can conclude in this dark ring spectrum, the diameter of the dark rings are proportional to the square root of natural numbers. Square root of natural numbers. With increasing in the order of n, with increasing the order of n, we can get it the very close, and the fringe width also decreases. Just to see that in this diagram, the order of the ring increases. The first order, second order, third order, fourth order, fifth order, sixth order, up to n number of order. So first order means the gap should be much more, the width is a I. But you see that the nth order, the width is very low, the width is a decreases. So order of the spectrum increases means the fringe width decreases and the fringe very the ring patterns occur on very close. So based on in this Newton ring experiment, what are the application we can use it, what you determined in these applications with the help by Newton's ring experiment. So we can determine of wavelength of light source. Another one is a determination of refractive index of any liquid. So in these two applications we can calculate by Newton ring experiment. So first applications, determinant of wavelength of a light source. So in this wavelength of light source can be calculated by measuring the diameter of the various rings and knowing the radius of the curvature of the plano-convex lens. So in this spectrum, let us R be the radius of the curvature of the plano-convex lens. Lambda is the wavelength of the light. Dm and Dn or the diameter of the mth and nth ring. So based on in this condition that is already studied in this Newton ring experiment, we can calculate what is the mth ring condition, what is the nth ring condition. So already said that here let us consider for the dark fringe conditions. Okay, so the dark fringe conditions means before theory of Newton rings we can derive it. Yeah, d square equal to 4n lambda r. So in this above this equation derived from here. So in this equation only we have considered, yeah, d square equal to 4n lambda r. So n is the order of the spectrum. So here we have considered for the mth order. So that only the n can be replaced to m here. So dm square equal to 4m lambda r. This is the first equation. Next, the first ring we have considered. Next, second ring we have considered. That is the nth ring we have considered. So dn square equal to 4n lambda r. 4n lambda. So both the equation you can subtract. So nth ring minus mth ring. Dn square minus dm square equal to 4 n lambda r minus 4m lambda r. 4 lambda r constant, take it common outside, n minus m. 4 into n minus m into lambda r. So in this equation, lambda is a wavelength. So what you determined, wavelength only we can determine. So lambda only I will kept it here. One side, remaining term move on opposite side means, so remaining term is a multiplication term, move on opposite side means division term. So lambda equal to dn square minus dm square divided by 4 into n minus m into r. 4 into n minus m into r. So this is the wavelength of the light source. So this is the general equation. Then we can find that which type of source light we can determine the wavelength of the light with the help of this formula. So how to do the procedure means, already we have discussed in the experimental arrangement by the Newton ring experiment. Same procedure, but in this source here, what type of source we have used, that source only we can calculate it. So the experimental arrangement, after completion of this experimental arrangement, the forming of the Newton rings, the microscope is adjusted so that the center of the cross wire, first of all you can adjust the cross center of the cross wire is adjusted at the center dark spot, at the center, in this spot, center dark, center center dark spot of the ring pattern. By counting the number of rings, the microscope is moved to the extreme left or right of the pattern, and the cross wire is adjust tangentially in the middle of the dark ring. So the readings are noted by the microscope. Then the microscope moved from the left and right, you can find that what is the ring position. The values can be calculated. Then the values will be plotted. The graph is plotted between the number of rings and the square of the diameter of the ring. Then you draw the graph means you can get it one straight line. Then you can find that any two position of the ring we can consider. So this is the mth ring, another one is a nth ring you have considered means. So the mth ring, what is the corresponding diameter of the ring? Nth ring means what is the corresponding diameter of the nth ring? We can calculate it with the help of graph. So you can write it, the equation means that is a AB minus CD. So the AB means what, dn square minus dm square divided by n minus f. So this is a graph calculation formula. So based on this equation, what you determine means that is the radius of the light. But what are the parameters you know means the remaining term, the above you see that in this formula, 4n minus m. So this is the nth order, this is the mth order. So this is also constant. So lambda value means diameter of the ring, you know that. R is the plano convex lens. So in this plano convex lens, what is the radius of the curvature? So in this radius of the curvature, we can determine with the help of spirometer. Then R values also, you know, meet all the values substitute here means you can get it the wavelength of the particular light source. Okay, so next to go for determinant of refractive index of a liquid. So in this experiment is performed when there is a film between the glass plate and the plano convex lens. Then the plano convex lens and the glass plate setup is placed in a small container. So in this container name we mention that C. Here used the transparent liquid of refractive index introduced between the lens and glass plate, in this glass plate as shown in this diagram. After that, the springe pad, the circular rings occur in this Newton ring experiment. That is a Newton rings formation. Then we can calculate what is the diameter of the mth and nth dark ring are determined with the help of traveling microscope. So in this, yeah, first of all, you calculate what is the general equation means dm square minus dm square equal to 4n minus m into lambda into r. So this is the equation number 1. The plano convex lens and plane glass plate, plano convex lens and the plane glass plate is placed into the container which consists of a liquid whose refractive index is determined. That is unknown liquid we can determine. So in these cases, the air film is replaced by the liquid film. Then the diameter of the mth and nth dark ring are to be obtained. So in this m and nth dark ring, diameter of that particular liquid, we can indicating for d dash. Now we can write it what is the general equation means. So dn dash square, that is the diameter of the particular liquid, that is unknown liquid, unknown refractive index conditions, we can write it dash. So dn dash square minus dm dash square equal to 4 into n minus m into lambda r divided by mu. What is the meaning of mu? That is the refractive index of the unknown liquid. So here why you are not mu value substitute 1 means you get the same value 4 into n minus m into lambda r. So that only not indicating here. Okay, so in this equation number 2, so then the mu value division term on left hand side means multiplication. So mu equal to d n dash square minus dm dash square equal to 4 into n minus m into lambda r. So now the equation number 1 and the equation number 2, the right hand side, just you compare that. Mu equal to dn square minus dm square, the left hand side, that is equal to this value can be replaced to this value. So mu into dn dash square minus dm dash square equal to dn square minus dm square. So we want only mu value. So mu value only kept it left side, remaining term on right hand side means already the right hand side the dn square minus dm square divided by this multiplication term on right hand side means division. So dn dash square minus dm dash square. So this is the refractive index of that unknown liquid. So based on the Newton ring experiment, we can calculate so many parameters. For the example, diameter this formula. So based on what are the known values you remaining parameter, we can easily determine it.